Okay, then there is word embedded with some designated dimension, and there will be another positioner embedding. So each of the word they will have position. So there will be positional embedding with two-dimensional vector. Then they will add each. Then some vector will come out for each of the token, right? There will be three two-dimensional vector. Then what we need to do is now we should make the key query value for this token and also of this token, but it's same, so I will only feed this example. What we should, how can we make this is simple. We should multiply this vector with weight matrix for key, and weight matrix for query, and weight matrix for value. Then we will do linear algebra. So we, if it is 2 by 1 matrix, wait a minute, weight matrix should be then 1 by 2 matrix. I'm a bit confusing. Yeah, I'm confusing. Wait a minute. Yeah, I think I have some error here. Anyway, if we multiply this, then we can get key matrix for this one and query matrix for this one, and there will be value matrix. Then what we will do is we will keep the value matrix. And with key matrix and query matrix, we have key and query matrix for let's and let's, and there will be also key and query matrix for do, and key and query matrix for free diving. What we are doing is we will make 3 by 3 matrix. Dot product or inner product, here it will be key and query of let's, and here will be key let's and query for this one, and key let's, this row will be for key let's and query of others, and this row will be query of let's and key of do and free diving. Then we can notice there will be 3 by 3 matrix. Does it make sense? Then after making 3 by 3 matrix, we will apply soft. What was I forgot the name of the function. Soft something, which is we use it in deep learning a lot. What we are doing is by doing this, we will there will be another 3 by 3 matrix will be come out. Just do some mathematical computation, which is in each of the denominator we will add same row, and each of the component will be on the numerator. So we will make this matrix, and also for second row we will do same thing, and for third row we will do same thing. Then there will be 3 by 3 matrix will be come out, and this is attention rate matrix. From attention weight matrix, what we will do is multiply attention weight matrix with value matrix that we made here, 3 by 3, and then value matrix should be also 3 by 3. Then multiply attention weight matrix and value matrix, then we will get attention matrix. Okay, wait a minute, I will pause it. Okay, I got a question, which is why are we doing this? This is attention, so this is kind of what we call dot product attention. We can write down in a very simple mathematical format, which is softmax function for Q query transpose and divided by root D, which is dimension, and multiply by I forgot it. So this is we call it dot product attention. Good question. Why are we doing this? Now I will give you some intuition in respect to computer science field because we are majoring in computer science. Do you know the concept of dictionary? Then let's think about
You mean dictionary book, right?
and also Python's dictionary.
No, then no.
Okay, I will explain it. If you see the dictionary, why are we doing this? If you see the dictionary, do you know the JSON format? JSON is very similar with dictionary, Python's dictionary. If you see the JSON, then there is curly bracket, and with this dot there is key, and there is value. Can you remember it? And with each of the comma, there is another key and value, and another key and value, and another key and value. And let's think of this. This file system is really dictionary. Really dictionary. Or let's think of it as the program that we developed during the web programming class. This is our servers, database, let's say database. Or let's say Google or whatever. Google, if we very simplify what Google has, Google will be same. There is key and there is value. Then there is query, which is how we ask to Google. Question can be how much is the equipment for free scuba diving or something. This is a bit complicated, so let's just say this one. Then what Google should do is bring the information that you asked, query. But the problem is how can Google find the correct information? Google should find Google will return the value. The problem is Google doesn't know which value to return. Does it make sense? Do you have any good idea? What should you return?
No idea.
But you know that we should return the answer, right? Or at least similar one. Then the question will be, how can we find the same one or similar one? Because there will be nothing same with really query, because you can ask how much is it, but you can say maybe in Korean, or you can say in grammatically wrong way, or you can say in different way, or slangs or something. What we will do is we will calculate how each of the key is similar with query. How? We will change query to do the embedding, and we will also do keys embedding. Then it will be vector and it will be vector. If there's two vector, you can calculate inner product, right? And inner product can imply the meaning of similarity. So what we are doing is we will return the most similar one. So we are calculating how much similar each of the query, that embedded query and key is similar. And we will check. We are not just returning the most similar one, but we will make kind of average. So we will check each of things, how similar are they? And there will be more similar and there will be less similar. Let's say 60% and 40%. Then what we are doing is multiply 60% of weight in this and multiply 40% of this. What we are returning is value, because key is just representative of value. So we are multiplying 0.6 of weight and 0.4 of this value corresponding to key. Then we will return the answer, which is weighted sum of this value and this value. Then what we will have is kind of value, kind of in between this kind of thing that is similar with this query. So, does it make sense? Understandable, or do you have any questions?
Kind of understand, but I don't really understand what's happening right now. But I
okay.
kind of understand what they're doing.